Now we start probability. I think you'll find this a nice break from what we've been doing. It's fairly easy to, in the beginning at least. We're going to use discrete examples which make things go a lot more smoothly. We're going to look at how probability quantifies randomness and things that happen and there's no set pattern to them, or what we call random. So when we have small numbers of them, what you think might happen next looks a lot different than what happens in the long term. So summary statistics settle down when we have a large number. Summary things are like averages, median values, things like that. So the more observations we make, more times something gets closer and closer to a certain number we would expect. And this long run proportion provides a basis for definition of probability. So when you look at this, we're looking long term. If you're looking short term, it does not really work. So if we toss a die, it has dots on it, we look at the dot that's on the top side. It's a 1, 2, 3, 4, 5, or 6 dots. So if we throw it and there's the 6 dots on the top, we call it a 6. If we do that a whole lot of times, the ratio of how many times it comes up with a 6 on top compared to other things that happen, it gets closer and closer to 1/6. So that's what we'll call a probability. Its value is always between 0 and 1 and includes 0 and includes 1. So what is called a fair die means if you throw a die with the dots on there, you have equal probability of getting a 1, 2, 3, 4, 5, or 6. And at the bottom you see probability of 6 equals 1 out of 6, 1 over 6. So when you do one of these throws like that, it's called a trial for the die or any kind of random phenomenon. And they're independent if the outcome of one trial is not affected by the outcome of another trial. So if I throw a die 6 times, all of the throws are separate from each other and they have no influence on each other. That's what we mean by independent. And that's the law of averages if you're a gambler, the law of large numbers if you're a statistician. So let's see what we get in particular. So we're going to assume that many times that the possible outcome of a phenomenon is equally likely. Like you have exactly the same chance of throwing a 3 with a die as throwing a 6 or a 1. So we're going to estimate the actual probability a lot of times by getting a sample, but it's imperfect. So the relative frequency is what we're always going for. And we'd like it for a large number of trials, but you can't always get a large number of trials. So sometimes what we have is something that's more subjective. And it's not quite as subjective as you would think. I mean, that's a term we use, but it's slightly different meaning here. So Bayes was a statistician who came up with weights predicting outcomes for horse racing. Knowing how horses did in prior races gave him an idea of which horse would win the current race. So that's not totally out of reason. So his belief was based on fact. So they'll say it's subjective. But it's only kind of subjective. And we stop here for this one. The next section, 5.2, will be much longer.